Hello, I have a question on section 1.6, absolute value inequalities. Now we went over some that you do the mechanical form, but there's like exceptions to the rules. And this is when you have negative numbers that appear on the other side or zero. And so basically it comes down to, is it all reals versus no solution? Okay, so the problem that people have with these problems is that whether they work or not. So when you have a negative number on this side, probably your best bet is just to put a number in for x. If it works, then it's going to be all real numbers. If it doesn't work, then it's going to be no solution. That's what happens if you end up with a negative number on this side, and that would probably be your safest bet. Now, if you follow the definition, you wouldn't even have to think that much. You wouldn't even have to put a number in at all, because this says absolute value, okay, which is a distance from zero, and the question becomes: is the distance from zero, whatever that x is, greater than or equal to -2? Well, obviously, if you have a distance, it's going to be bigger than a negative number. So what comes out of an absolute value will always guarantee to be positive. So if you put, let's say if you don't remember that, you know, so well, let me put a number in. Well, you put 2 in, or whatever. 3 times 2 is 6. 6 minus 5 is 1, and the absolute value of 1 is 1. And remember, when you put a number in there, you're going to take the absolute value of it, and whatever comes out of it is going to be at minimally 0. Okay? It cannot be negative numbers because the absolutes are distances, and distances will be positive or 0. So whatever number you put in there is going to be guaranteed to be greater than or equal to -2 because distance is greater than any negative number. So if you put -2 or -20, it wouldn't matter. So, or -21, it really wouldn't matter what this number is because this number, whatever number you put in, will be guaranteed to be greater than or equal to 0. So this one is going to be one that has all real numbers. So it's -infinity to infinity. So that's the answer if it's greater than negative numbers. Now, what happens if it's less than or equal to negative numbers? Well, again, you can just put a number in and see if it works or not. If you put in like -4, I mean, I'm just pulling that number out of the air. 2 times -4 is -8. But when you take the absolute value of -8, it becomes a +8 because it's the distance from 0. And 8 is 8 less than or equal to -50? No, it's not. So any positive number that you're going to end up with there, or 0, will never be less than -50. So, like I said, if these trouble you and you can't remember the rule, well, if it's greater than it's one thing or it's less than it's one thing another, just put a number in there, and that'd probably be your safest bet. So this one here would be no solution. And I've been asked lots of times, can I just put the empty set? And that's fine as well. They're synonymous, so you can put either one. Okay. Now this one, 2x minus 6 is greater than or equal to 0. Now again, this is kind of like example 1. Now, this one right here, if you put in, let's say 5, 2 times 5 is 10, minus 6 is 4. 4, absolute value of that is 4. Is that greater than or equal to 0? Yes. Okay. Now, there is a number that might say, well, what about 3? Well, 2 times 3 is 6. 6 minus 6 is 0, and the absolute value of 0 is 0. The question becomes, is 0 greater than or equal to 0? And the operative word is or equal to. And so, yes, 0 is equal to 0. It's not greater than, but this is red. This is red, greater than or equal to, not and equal to. So 3 would actually work as well. Now, so this would here would be all real numbers, just like example 1 is. So now, if you modify this problem like this one, like 5x minus 15, and let's make it greater than the absolute value of that. If you make it an absolute value of it and just make it strictly greater than 0, it's again the same idea, except when it's 3, it becomes 0. 5 times 3 is 15. 15 minus 15 is 0. Absolute value of 0 is 0. Is 0 greater than 0? No, it's not. So 5 would not work because that's what makes it equal to 0. Any other number would be fine except for 5. So because negative numbers, when you put a number in here, like for example, -4. 5 times -4 is -20. -20 minus 15 is a -35. But when you take the absolute value of -35, it's 35. And 35 is greater than 0. So even that number works. So the only problem with this one is the number 3 itself, because 3 would make it 0. So it'd be -infinity. Oops. -infinity to 3, union 3 to infinity. So this is really, we'll call this one example 4. So, but these are like 4 different scenarios that you might have. when you deal with absolute value inequalities. And these are the ones that don't fit in the same category as the ones we talked about prior in the class. So, but this is the idea when you have negative numbers on the other side. But like I said, when there's negative numbers on the other side, which is probably more common than this example right here, don't let them mess you up, okay? Because it's not, you don't follow the same category like we did before. But what you can do is put a number in. If it works, then it'll be all real numbers. If it doesn't work, it's no solution. Instead of trying to remember which one goes with which one. So, and that is it.